Hello, viewers. I am Kyungyeon Ra at Purdue University, and I'll be talking about school building water quality study conducted in Indiana. The purpose of this study was to better understand water chemical and microbiological quality between summer and fall seasons within the school building. This is a 7-year-old LEED certified middle school with little more than 800 students attend during normal semester. On the weekend, they have church services, and they have activities like summer camps during the summer. The building gets public water system from two different plants, about 75% from groundwater-based well field, and 25% comes from surface water, and the water is chloraminated. Their plumbing system is copper. They also have hot water recirculation system and water-saving devices. We visited the school total of 6 times, 3 in the summer, 3 in the fall, and collected samples at 7 a.m. every visit. During each sampling trip from each location sampled, we collected about 150 ml in the beaker for the field measurements. Then, we collected about 2.8 liters for different water quality analysis. According to the utility, corrosion inhibitor was not added, but they focused on maintaining alkalinity and pH. This is the satellite view of the school, and the water comes from the public utility that circles around the campus about 3.4 thousand feet, and finally feeds into the utility room of the building. Based on the as-built drawing, we counted a total of 363 water outlets in this building. Although we were only able to sample few locations of all, we tried to balance out where we sampled. During the summer, north part of the building is the most used building portion, and the south part of the building is the least used building portion. So, we started sampling from the utility room where the water comes into the building in red arrow, and then we went around the building to sample. As you see, there were 4 different hot water recirculation lines as well. On the last visit, we sampled additional random locations that are in blue words because we found some copper problem, so we reported school, and the state agency recommended school to flush those faucets. So we wanted to see the water quality at other locations as well. From on-site water quality measurements, we found that water quality enters the building was consistent throughout the sampling events, but it was different than water quality reported by public water suppliers' annual report. Of all water samples, 68% had no detectable disinfectant residual, and only 2 of 6 entering water made the Indiana water quality standard for total chlorine residual, which was 0.2 milligrams per liter. Copper levels exceeded the health-based action level noticeably at cold water. More than half of the total first draw cold water samples exceeded the copper action level. Copper in cold water levels significantly reduced after school began, but not differ in hot water. As distance from the water meter increased, copper concentration also increased for both cold and hot water. Flushing individual fixtures did not consistently reduce copper levels and sometimes exceeded at new locations. Copper level rebound was also observed. Other organic and inorganic contaminants were also found entering the building, but within levels reported by the water supplier. Since the building gets chloraminated water, there is a chance of biological oxidation, which is nitrification. We use BART test kits for both nitrification and denitrification in selected locations. Nitrification was found in all hot waters and some cold waters. Denitrification was less frequently found. According to literature, a typical nitrifying bacteria concentration in a chloraminated surface water was less than 850 CFU per ml at the water supply. The water comes into this building also had a pretty low number of nitrifying bacteria, but high concentrations were observed in hot water after water softener, especially during the summertime. HPC levels increased in the short distance from the entry point to the softener during the summer. HPC levels also gradually decreased after the heater tanks, but then increased again. So, what did we learn? In order to understand the water quality of the building, we also need to know how water is transported, stored, and used. Flushing cannot be relied to be only one solution to reduce copper levels because it may depend on building characteristics or rebound. So we recommend a periodic water chemical and microbiological testing to maintain the building. Thank you for listening. If you have any questions, we have a lot more information at our webpage. You can also contact Dr. Andrew Welton or myself.